Here's an example of completing the square where the numbers don't come out very nice. So, when the leading coefficient when you're completing the square is a 1, everything is nice and easy. But when it's not a 1, like in this example, the calculation can get a little messy. And it's not impossible, it's just that it's a little messy because you have to deal with some fractions. So our leading coefficient here is 9. Now our trick for completing the square really only works when the leading coefficient is 1. So we have to make the leading coefficient 1 by dividing both sides of this equation by 9. Right? Now on the right, of course, that doesn't change anything. We still have 0. But on the left, 9p squared over 9, that's p squared. And then minus 12p over 9. 12 over 9, that's 4 over 3. So 4/3 p minus, and then 1 over 9, that's 1 over 9. Okay, now we can do the same thing that we usually do when we complete the square. It's just that we're going to have to use fractions. Usually we'll move the constant term to the other side, so we'll still do that. So p squared minus 4/3 p equals 1 over 9. Okay, now we take the coefficient on our first power term, minus 4/3, divide that by 2, and this is, dividing by 2 is the same thing as multiplying by a half, right? So we can get rid of a factor of 2. So this is minus 1/3. And then after you divide by 2, you square it, right? That's what gives you the missing piece of the square. So squaring minus 1/3 gives us 1 over 9. Oh, I dropped a 2. No wonder things weren't looking right. So I dropped a 2 here, right? Yes. Okay, so I should have a 2 here, and that means I need a 4 here. All right, so the missing part of the square is 4/9. So we'll add 4/9 to both sides. Okay, so now on the left we have p squared minus 4/3 p plus 4 over 9 equals 5 over 9. Right, 1 over 9 plus 4 over 9 is 5 over 9. Now this should be a perfect square. And the thing that it should be a perfect square of, so here's a little shortcut in case you haven't noticed this. After you divide by 2, that is what should show up right here. So if we did things right, this should be p minus 2/3 squared. Now that we know that's what it should be, we can actually multiply this out to see if we do get this line above. So p minus 2/3 squared, that's right, p times p, and then p times 2/3 twice that, so that's 4/3. So 4/9. No, 4/3. P plus 2/3 times 2/3 is 4/9. So you see that is what we had up here. So this is how it factors. And then on the right side, 5 over 9. Okay, now we just need to finish solving, right? We can take square roots on both sides. So p minus 2/3 is plus or minus the square root of 5 over 9. But the square root of 5 over 9, we can simplify that. So that's the square plus or minus the square root of 5 over the square root of 9. But the square root of 9, that's 3. So this is plus or minus the square root of 5 over 3. Okay, so p minus 2/3 is plus or minus root 5 over 3. And now we can move that 2/3 to the other side. So p is 2/3 plus or minus the square root of 5 over 3. Or if you want to, right, these do have the same denominator, so you could put these together. 2 plus or minus the square root of 5 over 3. I think either way of writing it, this way or that way, those are sort of equally simple. So neither one of these really counts as simplified, so either one is fine.